So today we're going to be taking a look at inventor relationships, and we're going to be taking a look at the constraint and the joint tools. We're going to look at some similarities, some differences, and some of the things that you can do with those. So to get started, just an introduction. You guys have seen me quite a few times on these webinars, and I got an updated picture of the family there. That was actually from Emma's birthday. It's her first birthday party. So we got a 1-year-old, and Kyla in my arms. She'll be turning 3 in about 2 weeks. Actually, a little under 2 weeks now. So we're gonna have a 1 and a 3-year-old running around. All right. So I wanted to start off today just by looking at a couple quick slides. Before I do that, I do have a couple polls for you, though. So we're going to start off with our first poll. And there's a couple different relationship types that we're going to be looking at. The constraint tool, the assemble tool, and the joint tool. And our first question here is just wondering which of those tools you guys have used. That is multiple choice or multiple answer as well, so you could pick all 3 of them if you've used all 3 of them. Alright, got most of you guys have voted. Looks like somebody's screwing around with me there. I'm going to go ahead and share those results. So you can see that 100% of you have used the constraint tool. About 38% of you have looked at the assemble tool, 25% at the joint tool, and 6% of you are screwing with me, I'm sure, by eyeballing them and using the ground option. All right, let's take a look at the next poll. So again, this is multiple answers, so feel free to pick a few of those. But when we're dealing with the constraint tool itself, just curious if this is the only tool you have used, if you've ever had an issue or never have an issue with it. A couple general responses there. Alrighty, let's take a look at some of these responses. A little bit of a surprise here. About 35% of this is the only relationship tool that you have used. That's about what I expected. Probably the same 35 said it can use some enhancements. Again, I'm surprised that number's not all the way up. But I'm a little bit surprised by that 88% number. I have had issues constraining my assembly. I'm sure that there have been some, but I definitely wasn't expecting a number that high. So hopefully today we can look at some other options or maybe some little tweaks in there that might help you out with some of those. Alrighty, let's take a look at the next one. This one is going to deal with the assemble command. So again, multiple options there. You can pick as many as fit your situation. You have used this tool, you use it as often as possible, you've never tried it, or maybe even never heard about it. Okay, let's take a look at some of these responses. So just under half of you have used this tool before, and the other half has never tried it before. And then a small percentage, probably about a quarter of you, have never heard of this tool before, the assemble tool. So we'll definitely get to take a look at that one and see how it can help us out and what we can do with it. And we have one more, and this is relating to the joint tool. Okay, look at some of the responses for this one. All right, so about half of you have used this tool before, and even about 14% of you use it as often as possible. That's pretty awesome. As far as those next three options, if you had asked me probably within a couple months ago, I probably would have fit into all three of these. I never tried it due to the lack of effort. And when I did try it, I might have had a little trouble understanding what I was looking for, or just didn't expect to work as I thought it would. And that's basically because I was used to the Constraint tool. Constraint tool did everything I needed it to do, and I didn't really see a need to change there. So probably about a couple months ago, I was challenged to give it a shot and see what I thought about it. So I started taking a look at it, and I've used it from time to time. There's a couple things that I really like about it. There's other things that I feel like are pretty good, but could be a little bit better. And then other things I'm just going to stick with the Constraint tool for. So hopefully taking a look at a couple examples, you guys can see exactly what I'm talking about, and maybe get some ideas of where you can implement the joint tool and the Constraint tool side by side in your assemblies. So taking a look at the Constraint tool, this is the most common one. Everybody's used this. I'm not going to spend a whole lot of time on this dialog box. There are a couple things that we will look at once we get to some examples, though. So first of all, dealing with the different types, we have the mates, we have the angular, the tangent, the insert, and the symmetry constraint. And I'm sure that you've used probably most of those. If you're like me, you avoid the tangent at all costs. Never really saw great use for it. I know there's been times I have used it, but try to avoid that one. And then, of course, with each of these, there's two or three different solutions for them. And again, a little bit of a preview of coming events. There's a couple of new tweaks in the 2019 software that I want to show you relating to a couple of these. The assemble command. So the assemble command, it used to be part of the ribbon a few releases back. It has actually since been moved, and I typically say it's been hidden. So it's on. You have to click the relationships bar to see it, and then once you start the assemble command, you get the mini toolbar like it's seen in that screenshot. And this is an advanced version of the Constraint tool. So it does, for the most part, just about everything the Constraint tool does, but the tool itself is going to help you out. So instead of choosing a type of constraint, so instead of choosing an insert or choosing a mate and then making your selections, you start the assemble tool, you start picking faces, you start picking edges, and then based on what your selections are, the assemble tool is going to basically determine what the best option for you is. And then you get an option to say, you know what, you decided mate, actually wanted flush, so you get a little drop down menu there to switch back and forth between them. But the idea of this tool is to make your constraining faster by helping you decide which tool or which constraint type to use based on the selections that you made. The joint tool. So we have a few different types of joints. We have an automatic joint type, which is pretty handy. Again, based on your selections, just like the assemble command, based on your selections, it's going to pick the type that it thinks best represents your situation. There's a rigid type, which is an extremely handy one, and we'll be taking a look at this one. This one removes all degrees of freedom between your selections. We have the rotational, which is going to allow one rotational degree of freedom. The slider type, which will allow one translational degree of freedom. And then we have a cylindrical, where it specifies one translational and one rotational. And the planar, which specifies two translational and one rotational degree of freedom. And we also have the ball type, which specifies three rotational degrees of freedom. Actually, I've never used the ball type before. I'm not sure if I ever will. But if you take a look at this dialog box, the idea is pretty similar to a constraint. We have the type that we pick. We have our connection options. We have alignment options as well. There's a gap value if you need it. And then on the second tab of this dialog box is the limits option, where we can assign angular or linear limits for our joints. All right, so there's the limits tab. So let's switch over to Inventor now. Like I said, I don't want to spend a lot of time in PowerPoint. That's really about all the PowerPoints I have until the very end. But I want to switch over to Inventor, and we can start taking a look at some constraints, joints, building relationships in our assemblies. I got a few different examples to show you. We'll cover a couple different situations. I'll give you some of my my tips and tricks and maybe some best practices you could take a look at as well. I'll show you one or two new features that are going to pop up in your Inventor 2019 software. So this first one we're taking a look at is my trailer hitch design. And I'm sure you guys have seen me use this as a demo before, but we want to start taking a look at constraining this, building it up together, and take a look at a few different situations. So the first part of this is going to fit into our hitch is going to fit into our receiver, and that's going to be our first step. This is a situation where I'm really still going to probably go with constraints on this. I tend to default everything to constraining with origin planes. I like to keep all my parts centered on the origin planes and then use those whenever I'm building up constraints. If you ask me why, the reason is pretty simple. If parts ever change, if they ever grow in size, get larger, geometry changes, which they happen often enough, as long as you're using origin planes, as long as you're keeping your parts centered, pretty good chance that your assembly is going to update just fine and you're not going to have any issues. If you start constraining between geometry, you run that risk of having to make some tweaks or changes on the assembly side whenever you update a part. So let's take a look at a couple here. I'm going to start off with my constraint tool. And in my constraint tool, I'm going to use the origin planes between the hitch and the receiver. And I'm going to find that plane first, that plane second. Looks like a mate type works just fine there, so I'm going to go ahead and click apply to that one. And then I'm going to grab the second one, click OK. I missed that second option. Maybe I missed the first option. There we go, got them now. Click OK. And now I'm able to slide this back and forth. So I need to line up those holes. Pretty straightforward there. I'll stick with the mate type. I'll grab the axis and the axis. I'm going to go ahead and click OK. It's actually giving me a warning, and this is a pretty good spot to show you guys a new tool or a new feature in the 2019 software. I actually didn't intend for that one to break, but I get a chance to show you that now. So if you take a look at my dialog box here, you can see that I have different solution types now whenever I pick axes. So those are new in 2019. That might give you one extra step that you have to select there, and we'll probably see that option show up a little bit later on too. But in this situation, I had to switch to a different solution type there. So a new option in 2019 when you're dealing with axes is being able to flip those constraints. I know a lot of us have been waiting for that for a while. Again, we'll see that pop up later on, so we'll see that again. So that deals with the first part of this. So the next thing I want to take a look at is putting down this chrome hitch ball into my design. I'm going to go into the joint type for this. Joint type for this, and I'm going to go with a rigid. But right before I do that, I did want to talk about maybe how I would go about doing this if I was dealing with constraints. So if I was dealing with constraints, I would probably go with an insert type, probably select that edge, and I have to do a flip there, and then click OK, and I get my part in there. Still have a rotational degree of freedom to deal with if you want to make sure everything's locked down, so that would be a separate constraint type. I'm going to undo that, and we're going to take a look at this rigid type constraint, which I'm really a fan of lately. A rigid type constraint, it works pretty much the same way as the insert in this situation. I'll grab that edge, I'll zoom in, I'll grab that edge in that center point. It's going to lock it down into place. A little bit of an animation there, which I could turn off or on, and I'm going to go ahead and click OK for that. And that's completely locked into place. I actually don't need to worry about the rotational degree of freedom on that guy, because the rigid is going to handle it. When we're taking a look at this pin, I do want to show you another option that popped up in 2019 on the insert constraint. So on the constraint tool, insert, and I select my edge, and I select my edge. Let's flip that around first of all. One of the problems with the insert type constraint, it's not really a problem, but just one of the things is if I click OK, that thing's still able to spin around in that hole. So that would be another constraint type we would have to do in order to lock it down. A new feature in 2019 is the ability to lock the rotation for an insert type constraint. A little bit of a problem there with that, though, is let's make sure there's no other options down there. Whenever you do that, it's going to rotate it to a certain point. And it could have went correctly, it could have went left or right, it could have went up or down, and you really have no control over where it goes. So for a situation like this, it's not really ideal. A situation like a bolt or a nut, that lock degree of freedom on the insert type is a pretty nice little trick there that they've added into it. So take a look for that checkbox once you get into the 2019 software, and you can look at that. So in our situation, because clicking that checkbox turned it to the side, I'm going to switch back over to a joint type, rigid type. I'm going to click those same selections. I'm going to place that in there. Now you can see it's still on its side on here, but I have some alignment options that I can do now. So I'll click that face, and then I'm going to rotate around until I can find the correct orientation. So it looks like using that top face is going to work, and then I'll just simply switch the alignment option there for me. So using the rigid, this time I had to do an alignment. Click OK. Again, that is fully locked down. The rigid is going to lock all degrees of freedom. And there we have our completed assembly. Let me go ahead and save this one. I'm going to close out of it, and we're going to take a look at the next one that I want to show you guys. This is a bolt lock, like you would typically see, on a sliding door or any kind of doorway or something like that. We'll take a look at that in a little bit. But what I want to do is show you a couple more different types of joints and constraint options that are going to pop up and that you can use to control your designs. So to start off with, this part is my grounded part that's connected to my origin, so that's what's going to be locked down. So the first thing I want to do is I want to constrain this guy in place and get it located. So I'm going to go ahead into my constraint tool, and I'm going to select the axis of that rounded part and the axis of this rounded part. And the reason why I want to do that is because now I get to show you the different solutions whenever we're dealing with axes that we didn't have in previous versions of software, new for 2019 feature. So I definitely wanted to show you guys those today. So we have different solution types that we can go with, this first one or the second one to flip whenever we're dealing with an axis to axis. I know I'm excited about that because that's been one that I don't know why it's never showed up in the software, so I'm definitely excited that's now an option. Got the correct orientation. I'm going to go ahead and click OK. I'm going to slide that guy away. Let's go ahead and rotate this. Let's add another constraint on these bottom faces to make those flush to each other. And then the spacing, we're going to deal with a make constraint here as well, just to fully lock. And that should be 0.75 gap. So those two are locked into place now. And now we're going to start taking a look at these next couple parts. I'm going to switch over to a joint tool, and we're going to take a look at, I'm just going to go ahead and grab a couple edges here. And again, you want to make sure that you're grabbing the right edge, the right orientation. So a little bit of finesse there, just making sure you get into the right area. When I make those two selections, it wanted to go with a rigid type. I'm going to switch that over to a cylindrical type. And you're going to see an animation of what exactly it can do. So you can see that it's rotating and it's sliding back and forth in there. That's exactly what I want. Looks like the orientation's pretty good. But before I click OK, I'm going to switch over to the Limits tab. That's the section there. I want that leading face. That's better. Make sure my numbers are correct. So animate that again. Still doing exactly what I wanted to. It is showing my hole is to the side. I want that to default upward. So I'm going to go with an align option. I'm going to pick that axis. I'm going to come up and I'm going to find another alignment that I can make that happen. Looks like it's pointing straight down. That's good enough because I can always flip it. And now before I click OK, I'm going to switch over to limits. So I'm going to add some linear limits. My starting is going to be negative 0.35. Current is left at 0. That's fine. And my ending is at 0.35. Make sure that my test numbers work out fine. We'll find out in a moment. I'm actually going to take a look at these ranges just to make sure. That looks like it's where it's supposed to be. So I'm going to set that back to 0 as my resting position there. I'm also going to add in an angular option, starting at 0, ending at 90 degrees. And I can do a quick test here before I close out the dialog box just to make sure that it is where I want it to go. That looks perfect. So I'm going to go ahead and click OK. We'll test that in just a second. I'm going to add another one, and this is going to be bottom edge there, and I'm going to find that inside edge. It wants to default to a rotational based on the selections that I pick. In this situation, I don't care that it spins. I'm going to switch over to rigid and then click OK. So let's take a look at this thing, see what it can do now. So with those types of constraints that I put in, you can see it can slide back and forth. I can activate the locking mechanism. So if you take a look, okay, so I can go right through that material there. So maybe I want to add something else here just to hold down or control the way that it moves. Some of you may know about this tool that I'm about to use. If not, this might be new for you. I'm going to take these two parts. That's my pin and my right-hand portion of the lock itself. I'm going to right-click on those, and I'm going to add them to a contact set. Then on the Inspect tab, I'm going to make sure that Activate Contact Solver is turned on. Mine still is, but it's usually defaulted to off. So with the contact set turns on, what's going to happen is I can still slide this back and forth, but it's not going to allow me to pass it through metal because it's going to sense that interference there. So now I get some control as far as using a joint and using a contact set as far as how that thing can move back and forth. All right. Let's go ahead and save that one. And then we're going to take a look at another one that I have to show you guys. And this is a vise assembly. In this one, we're going to use a handful of different types, maybe even show you a couple situations where I'll pick one over the other and the reasons why. So in this one, we have a few different things that I'm going to go with the joint tool here. And I'm just going to switch it to rigid right off the bat. And I want to show you how much easier some of these constraints are going to happen. So we got this plate here that's going to be mounted with those screws to the back of my vise here. And typically that would take at least 2, maybe even 3 constraints, maybe a couple inserts to align those holes. Maybe you can even do a mate between the back of the plate and the vise, and a couple flushes on the top and the side. So a few different situations there where you can actually constrain it. Dealing with the joints using a rigid type, I'm going to hover over the back of this plate. I'm going to find that point. Actually, I'm going to go with on this one I'll go with that point right in the middle. I'll find that point right there. I think that was a bad click. I'm going to redo that. That one doesn't have a center point I'm going to deal with. So I'm going to go with the top center point and the top center point of that particular face. That looks a lot better. And that's going to lock it in, and that's going to fully constrain that plate to the vise with one single joint. Next thing we're going to take a look at is using the rigid type as well for these screws. So I'll hover over the screws, get that correct edge, that correct point. Same thing here. Apply that one, get the next one, and apply that one. Again, fully constraining those screws and that plate down with one joint type each. So the next one to take a look at here, I'm going to take this plate and attach it to this plate. So I'm going to go with the joint again. And for this one, I've tested it a few times and I found the situation that I like. I'm going to go with the edge. Make sure I get the right edge here. Go with the edge of this one. So a couple tweaks that I need to make. You can see the preview is not where I expect it to be. Let's go ahead and flip that connection. And we'll also flip the alignment and then animate it. Looks like it's set to rigid, so I want to switch that maybe to slider. And you can see that it looks like it's sliding in the correct orientation. Screw holes are facing the correct way. But we want to set up a limit for this. And I'm going to go with a 0 for starting. And it's 75 for the ending. I'll click OK. And we'll take a look at that guy and see that it's moving exactly where I need it to be. Again, fully locked down except for that sliding ability there. All right, let's add a few more here. So I'm going to grab the midpoint of there, lock that down with a rigid. Sliding back and forth is still able there. And then let's add a couple more. I love using this rigid, especially for this hardware. It makes the hardware so much easier. You don't have to worry about dealing with the rotational aspect of hardware if you're using an insert constraint. One click, you're done. One type, you're done. Go ahead and click OK. Again, sliding that back and forth in that limit, seeing how that motion works. I'm going to switch over to a constraint type. I'm going to go with an insert here. And the reason I'm going with an insert on this one is because there is an eventual degree of freedom that I want in this case, and that's the ability for that handle to rotate. So I'm going to leave it with an insert. That way it is free to do that. And then down here we got a few more parts to put on here. So I'm going to go with some joints, and I'm going to use these planar types now. So these planar types, I'm going to find that midpoint of that face. I'm going to attach it to this face. You can see that animation happening there. That's fine. I'm going to go ahead and apply that, because the next step I'm going to do is I'm going to grab that face to this face. It's going to pop up with a message box asking you if you're sure you want to do that. I'm going to go ahead and click yes. And you can see that it's going to rotate into place there where I need it to be. I'm going to click OK. And I'm going to grab hold of it and move it around just to make sure that it's going to do exactly what I want it to. Other side, I'm going to do the same exact thing. So let me run through a couple planers here real quick. Grab that center point. Grab that center point. Apply that one. Grab those two. Click yes to that box. Make sure that the orientation is correct. Looks like that one flipped. So I'll click my flip button. Find the right flip orientation, the alignment there to get it facing the correct way with that keyhole facing out toward me. These two guys are going to slide together, so I'm going to make that easy on myself by switching back over and doing a flush type constraint on their end faces. Click apply for that. One thing I've noticed about joints, joints do not have the ability, let me switch down over here to planes, at least in the situations that I've used it, to pick up origin planes. So I try to make a liar out of myself by switching around here and finding one, but from what I've seen, I'm not able to pick up origin planes. Now, you remember at the beginning, I mentioned, hey, I like to use origin planes whenever possible, and there's certain situations that certainly demand it. Here's a situation that does. These keys, these keyways, these square cut keyways, are going to line up with these two holes in the bottom of my moving jaw. So what I can do is I can use a constraint type. I'll find the work plane that passes right through the center of one of those and line that up with the axis of the hole in the moving jaw. Apply that. I'm going to switch over to a rigid type because I got a couple of round parts here that are going to fit in. I'll zoom the rest of the way around, make sure I grab the right surface. I always tell people when I'm training and when I'm just talking about best practices and things like that, don't be afraid to rotate, don't be afraid to zoom in. I know we're dealing with a webinar situation here, so hopefully I'm not making anybody too seasick. And hopefully the screen's keeping up with me as well as can be expected. So a couple joints there, just to finish off that part of the design. So in this situation, now I have a working vise, slides back and forth as I want it to. You're going to notice one thing that's not necessarily a pet peeve of mine, but one thing that I wish that the joint tool was able to do. So as I slide this back and forth and I let it go, it's just going to let it stop wherever I happen to drop that mouse off at. I'm not a big fan of that. I'm not a big fan of that because if I have a drawing of this, for example, and I have some overall dimensions, maybe in the fully open and a fully closed position, I can very easily mess up those dimensions by sliding this thing around, or mess up drawing views, just things that I don't like to do. So what I'm going to do with this one is I'm going to go find that plate. I'm actually going to get rid of that slider joint that I put in there. You go ahead and delete that guy out of there. So when I do that, this thing is free to move around quite a bit now. So a couple things that I want to do is I'm going to add in a couple constraints, some flush constraints. We'll apply that one, and top and bottom, top to top as well. Before I switch to a make constraint to control the distance between these faces. And what I want to do with this is I'm going to click this double right hand arrow, and I'm going to use the limits option in the constraint dialog box itself. So I'm going to set up a maximum and a minimum. The maximum is going to be 75, minimum is 0. And one thing that I like to do with this when you're using limits, because if I click OK for this and I slide it back and forth, it's going to behave the same way, where it just lets go wherever I drop it off at. I'm going to edit that. I'm going to activate this checkbox to use offset as resting position. And I'm going to put a value in here. We'll put 30 in. The use offset as resting position is a really important option there. Now what happens is I slide this back and forth just to test the movement, see what happens, make sure there's no other interferences, and I let it go. It's always going to snap back to that resting position that I defined. Okay. So we took a look at a couple situations there where we can use some constraints, we can use some joints in order to define how we want to assemble things. And I hope I showed you guys some usefulness from the joint tool. At the very, very least, and the first one that I definitely want you guys to be using is that rigid option. The joint tool, rigid, anytime you're dealing with hardware, even you can see how quickly it was to put the plates attached to the jaws to my vise. That rigid tool is going to help you out quite a bit. It's going to save you quite a few different constraints there. It also locks down the degree of freedom. Even though in 2019 the insert command has that checkbox, it doesn't work. It doesn't work great because it has the potential to rotate your component and maybe you don't want it to. We saw that on my trailer hitch. So we can use the rigid, and then we have the alignment options. Best advice I can give you guys with that is to just spend some time working with it, get used to what it's asking of you, and remember, it's not the same as a constraint tool. So what you're expecting in a constraint tool, you shouldn't expect in a joint tool. It does work a little bit differently. I've typically always been under the impression that joint tool is more useful if you do have things that need to be in motion. But we saw some situations here where this jaw plate, no motion there, used a rigid one relationship, that thing's locked into place. On the other hand, moving back and forth this vise, I do want to move it back and forth, and I was able to accomplish that pretty easily using the joint tool, but it doesn't give me the added bonus that the limits in the constraint type has with the offset option as a resting position. So definitely a little bit of back and forth there that you're going to want to take into consideration. So the biggest takeaway and the biggest challenge I have for you guys is to, if you've never tried this tool out, or if you've stayed away from it for a while, if you're like me and you never used it just because of lack of effort and because a constraint tool always worked for you, you didn't have a problem with it, take a look at it, especially that rigid option. Give it a shot. If you have any questions along the way, feel free to reach out to myself or to our support team, and we can help you work through maybe a situation where you want to try it out. Let me bring back up that PowerPoint. A couple of generic slides here at the end. Definitely want you guys, actually before I do that, I have one more poll for you guys. And I want to launch that poll for you right now. And that's basically asking you, now that you've seen these tools in action, what is your next step there? Hopefully you want to see some of you guys trying out the joint tool. Yeah, I got a few of you picking that option. All right, so about half of you are going to give that joint tool a try. Another 20% of you or so are going to stick with constraints, but definitely want to try out that rigid joint option. And that's about what I expected to see. Try out that assemble tool as well. I didn't really give you guys a good demo of that one, but you saw where it's located at. And like I said, it works the same way as the constraint option, but it bases your selections and then tries to help you out there. Go ahead and close that poll. All right, so as always, keep an eye on upcoming Mesa events, including our webinars. Just a preview of coming events, a couple weeks. You're going to see the return of the Jared and Josh show when we take a look at what's new in Inventor and Vault 2019. You saw 2 sneak peeks today, so definitely tune back in to see what else is new in 2019. Missed a previous webinar, we do host those on our website, so definitely take a look there and see we're hosting them. We're actually going to be switching over to a YouTube type hosting, but you'll still be able to access them from our website. And as always, thank you guys very much for attending. Hope you guys learned some value out of this webinar as always. And if you have any questions, comments, or feedback, feel free to reach out to me. Questions, support related issues, you can reach out to our support line as well. Thank you guys. You guys have a really good weekend, and we'll see you next time.